Okay, this is sample problem 17.6. There are three different figures that we want to look at. Which indicator or indicators listed in table 17.3 would you use for the acid-base titration shown in A, figure 17.3, B, figure 17.4, and C, figure 17.6? Okay? So let's take a look at the first one, part A, which is figure 17.3. That's the titration of a strong acid with a strong base. The equivalence point is at 7. So really, in a sense, what you want to do is you just want to find a indicator that changes color near that value, somewhere near pH 7. So if you take a look at it, thymol blue changes color from pH 1 to 2.8, 1.2 to 2.8. That's pretty far from 7. It's not anywhere near the pH 7. Bromophenol blue, 3.0 to 4.6. That's not very close to pH 7. Methyl orange, 3.1 to 4.4. That's pretty far away, right? That's not close to 7. When you get to methyl red, that one goes from 4.2 to 6.3. That's not bad. I mean, that's pretty close to 7. If you look at the curve, see how how steep it is around 7? Quite frankly, the difference between pH 6 and pH 7 in terms of your titration of adding the base is so small that a value that changes color from somewhere around pH 6 is perfectly fine. So methyl red would be okay. So we'll write down here that methyl red, let me make this a little bit bigger. Methyl red would be okay. And then you look at the next one. The next one is chlorophenol blue. That changes color. Not that far off, right? 4.8 to 6.4. Again, that's pretty darn close to the equivalence 0.7, just how steeply it rises over there. So chlorophenol blue is okay as well. Maybe not the best, but they're pretty close. That would probably work okay. The next one, bromothymol blue, that changes between 6 and 7.6. That's definitely got 7 in it, in fact. It's right around 7. So bromothymol blue. That would be okay. Next one, cresol red, 7.2 to 8.8. Yep, that's really close to 7. So let's go with that one as well. And then phenolphthalein, 8.3 might be a little bit above 7, but it's not that far off. So let's go with phenolphthalein as well. Let me spell this correctly. Phenolphthalein is a fun word to spell, so let's go ahead and do it correctly. Phenolphthalein. Okay, so it doesn't have to be right on the equivalence point, it just needs to be near it. So, when the lowest value for methyl orange is 4.4, that's pretty far off, but methyl red 6.3 is pretty close to 7, so it's close enough. Let's take a look at figure 17.4. Same thing, we're adding a base to the acid. You can tell that you're adding the base because the pH is increasing, and it also says volume of sodium hydroxide added. So we're becoming more basic. So again, the equivalence point here is it's a little bit above 8, right? So we want to find indicators that have color changes somewhere around 8. So probably bromothymol blue, cresol red, and definitely phenolphthalein would work. Bromothymol blue 7.6, possibly. We're getting pretty close to there. But definitely cresol red. And phenolphthalein. Bromothymol blue is questionable. It's pretty close. I suspect it would probably be okay as well. And now the last one's going the other way. We're adding an acid to it, so the pH is dropping down. The equivalence point is between 5 and 6. So again, we want to have a color change occurring somewhere around, between 6 and 4, somewhere around there, I guess. So if we take a look at thymol blue, that's pretty far off, 1.2 to 2.8. Bromophenol blue, that's possible. That's 4.6. 4.6 is pretty close. Methyl orange, 4.4. That's not too bad either. That's pretty close to 5.2. And let's see, methyl red, 4.2. That looks okay. Chlorophenol blue, 4.8 to 6. That's right on top right there. So that's not too bad. So probably those would be okay as well. So let's do all three of those. Let's do methyl orange. I'm sorry, bromophenol blue. These are really fun to pronounce. Bromophenol blue. It's pretty close. Methyl orange. Pretty close. Methyl red. Also pretty close. And then chlorophenol blue is 4.8, so that's not bad as well. What about bromothymol blue? Well, that's about 6 to 7.6. So that really doesn't start changing color, or really I should say, it might start changing color a little too quickly. It's going to change the color at 7.6. It'll have changed color completely by the time you get down to pH 6, and that's still above the equivalence point. So that's probably not too good there. There you go.